A wholesaler finds that the weekly demand Q is a linear function of the price P of a product. Let me draw an example of the axes that would be used to graph this type of problem. They said that Q is a function of P, which means that price P is on the horizontal. Now, when a company tries to investigate what the demand relationship between quantity and price is, they might try experimenting with different prices. Okay, setting the price at one level and seeing how many of those units sell, and then trying the price at a different level and see how many units are sold at that price level. So that's how they can gather some data historically in order to inform how they should set the prices in the future. So in this case, they set the price at $50. So let's put a 50 here. And they found that 350 units were sold at that price. They also talk about setting the price at $100. And in that case, they found that 250 units were sold. So the idea being the higher price had deterred some people from buying, whereas the lower price had made it more attractive to people. Now, if they were to collect more data points, we would expect that they could get a whole series of dots with which to make some kind of regression model from. They could model it as a line if they want to do the most simplistic approach. So that would be just doing a y equals mx plus b type of regression. And that's the type we're going to do in this problem. However, it's interesting to note that they could try other curved models as well, such as an inverse type of curve. Perhaps something like this would be more realistic. But anyway, for now, all we have is just the 2 points to go on. So let's use those alone to make our regression model. And we just need the best fit line that goes through those 2 points. Because they're the only 2 points involved, our line is going to touch both these points. Let's go to Desmos.com and get the function for this demand curve. Okay, so I'm going to put my points into coordinate pairs here. My first coordinate pair is going to be 50, 350. Alright, so going off this information here, we're going to create our first point, and that's going to be 50, 350. We want the price to come first because it is the horizontal variable, and we'll let Q come second, that's the vertical variable. We have another point to work with, 100, 250. And I just want to transfer these 2 points to Desmos. We could type them in as coordinate pairs and then zoom out and look for them. That's one option. However, in order to do the regression, I'm going to put them into a table by clicking the plus and adding this table here. So just type them in exactly as they appear as coordinate pairs, but we'll put the 50 in one column and the 350 in another. Then in the next row we can put our second point, which is 100, 250. As you can see, the points that I created are exactly the same as when I had entered them as coordinate pairs. Now we can do regression on these points. So let's type in the command y1 tilde mx1 plus b. In Desmos, this is the method for creating the best fit line between points. And we get a slope of -2 and an intercept of 450. The m is our slope, the b is our intercept. So let's copy those numbers down here. All right, now that we have the m and the b, we want to put them into a line equation. Now, lines have the slope-intercept form of y equals mx plus b. And so we just want to plug in our m and our b and leave the y and x as letters. And there we go. We created the best fit demand function. Okay, now I'm going to modify my formula here to reflect the situation. Instead of using the letters y and x, I want to use q and p. So let's write it as q equals -2p plus 450. That's better. Now that we have this demand function, okay, so now we have this relationship between units and price established. We could use that relationship in order to make predictions about how many units will sell at a given price. And we could pick any price of our choice. Just quickly, for example, if we wanted to know how many units would sell for a price of $75, you could plug that in for P and then solve for the expected demand. And it would be, in this case, $300. That would be good use of the model. That would be an interpolation to do that. But this question wants us to go even farther than that. They want us to find a revenue function. Now, revenue has a formula. It's always going to be found by multiplying a number of units that are sold times the price that those units sell at. But what makes this problem a little complicated is the price and the units sold have a relationship where the price is not just constant, it's a variable. And so what we see is this is a function of two variables where the price is set by the wholesaler, but the demand is a function of the price. What we want is we want to let the revenue be a function of price as well, instead of letting it be a function of two variables. In order to do that, I want to replace Q with a formula. And the formula to use is this one. So I'm going to take this and plug it in here. All right, now we have the revenue as a function of just price. So let's see if we can plug in these different values that they're looking for. They want to know what's the revenue if the price was 0. So all we have to do is replace the P with a 0. And in this case, we're going to get 0. The company won't have any money paid to them if they set a price of 0, of course. Now they ask, what is the revenue if the company was to set the price at $50? So that point is right here on the graph. We know how many units they're going to sell, 350, and we know what the price is going to be. It's 50. So we could plug it into this formula down here if we want. And let's see what we get from that. I get 17,500. An even easier way to get that answer, though, would be to simply multiply the number of units sold times the price that they sell at. So just 350 times 50. And that gives us 17,500. Now they're asking us, what is the revenue generated if the price were to be $225 according to the model? Okay, so now we'll find R of 225. I get a revenue of 0. So apparently this must be actually where the curve will intersect the horizontal axis. This is a price of 225. All right, now the next question says, at what ideal price will the maximum revenue be generated? For that, we can just look at a graph of the revenue function. So the revenue function is this one here. And I just want to plot that in Desmos for a moment. I'll go to a new field. We can type in that we're going to multiply negative 2p plus 450 times p. It might be a little unclear of what it is at first, but if we zoom out using the wrench tool, let's just change the axes, we can see that it's actually making a parabola. And so the green here represents our revenue. The maximum revenue occurs at the peak. And so if we just click on the peak in Desmos, we can see the ideal price to set that maximizes revenue. Apparently it's $112.50. And then if they ask for the maximum revenue that can be generated, we want to get the vertical height of that parabola. So that is 25,312.50. So in this problem, when we graph the revenue, the horizontal location of the peak tells us the ideal price for maximum revenue, and the height of the peak will tell us what the maximum revenue is.